Hi, everyone. Mr. Glover checking in. We do our first lesson over Zoom today. So before we do anything, I just want to say I hope that everybody's making out all right at home in this difficult time. I hope everyone's healthy and managing to keep their sanity, even though we might be getting a little stir crazy at this point. Um, I'm going to try my best to make these available daily for you, and I'm going to try to keep them fairly short, just so that I'm not using up too much bandwidth on your end, and that they're manageable. So with that said, we'll dive into the notes. If you remember before the break, we were working on factoring quadratics, and there was a few cases. There was a case where you had a leading coefficient, that was 1, and that was just something like x squared plus 2x plus 3. We had something that was called the difference of squares, which was something like x squared minus 9, where both terms are squares. And the other case that we had was when we had a leading coefficient that was not 1, something like 2x squared minus 4x plus 2. And basically, we'd spent the last week or so trying to figure out strategies to factor these. So the idea with today is we're going to be using these strategies to try to actually solve some problems and to solve some equations. So before we can do anything else, we'll talk about what's called the zero product property. And it's this idea that if two products of two real numbers is 0, then that tells you that one of them has to be 0. One of them must be 0. And that's something that I think most people wouldn't argue with. If two things are multiplied together, call it A and B, one of those things has to equal 0, or both of those things have to equal 0 in order for the product to be 0. So we're going to use this with quadratics to figure out what the solution for x is. For example, solve by factoring, then verify your solutions. So this one, we've got a quadratic equation. It's an equation because it equals 0 instead of just having x squared plus 6x plus 9. We've got to factor it and then use our factored form to try and actually find a solution for x. So we need two numbers that multiply to 9 and add to 6. And those numbers are going to be 3 and 3. So we can break this apart into x plus 3 times x plus 3. And technically, this does still equal 0, so we should keep the equals sign over here. And then we have to look at our brackets, and we need to think about what would make those brackets equal 0. So because one of them must equal 0, we can say x plus 3 has to equal 0. Or in other words, x has to equal negative 3. And it's a good idea to take this, go back, double check that it actually works. We'll do this for a few of these. So we can take our negative 3, plug it back into our equation. Negative 3 squared plus 6 times negative 3 plus 9 equals 0. It'll be 9 minus 18 plus 9 equals 0. Or 18 minus 18 equals 0. Or 0 equals 0. So what we did is we just verified that our solution works. So that's enough information for me to know the answer to this question is x equals negative 3. So quick recap, we factored the equation, which means writing it in a pair of brackets being multiplied together. We took one of those brackets, we set it equal to 0, and then we solved for what x must be. So let's try one that's going to be slightly more difficult. This time we've got a 2 in front of x squared, so our leading coefficient's not 1. That makes it a little bit more painful, but it's not too bad. So we take the 2, multiply by the minus 5. So 2 times negative 5 equals negative 10. And then we have to start thinking of some factors of 10. We can list them out. We can go 1 and 10, or 2 and 5. And that's pretty much it. Now we've got to think of which pair can we use to add to 9 and multiply to 10. And the only way we're getting there is with 1 and 10. So I know it's these ones. One of them has to be a negative because it's got to multiply to negative 10 and add to negative 9. So I'm going to say the negative has to be 10 because negative 10 plus 1 is negative 9. So at this point, we can now take our original equation, rewrite it, and split it up. So we'll take our equation, 2x squared minus 9x minus 5. Technically, it equals 0. I'm going to ignore that part for now. I'm going to split the 9x up into negative 10x plus 1x. And we still have our 2x squared, and we still have our minus 5. We then put our brackets in. And we have to try to simplify these brackets as best we can. We look at our first set, and both terms have an x in them, but both terms also can be divided by 2. So we can pull out 2x. 2x times x minus 5. And the other set of brackets already is x minus 5, so we can just say plus x minus 5. If it wasn't, we'd have to factor something out in order to make the brackets equal each other. I'm going to write a 1 outside though, so I don't forget that there is still a 1 being multiplied there. So now I can factor this. I can write it as 2x plus 1 times x minus 5. Now I can bring back the fact that this equals 0. Technically, we probably should have done it the whole way, but as long as we remember at the end, that's the important part. So we've got two possibilities here. Either the first set of brackets equals 0, the second set of brackets equals 0, or they both do. So we'll have to sort of treat them separately. We'll start with 2x plus 1. 2x plus 1 equals 0. We'll write it out by hand for now, but a lot of times once you've done this for a while, you can just figure out what x is by looking at the bracket in your head. For now, I'd like to see the work. So 2x plus 1 equals 0, move the 1 over. 2x equals negative 1. We need to get rid of our 2. So x equals negative 1/2 is one of our solutions. A quick trick, if you have a set of brackets that looks like this one, you need to make x the opposite sign. So if this is plus 1, x is going to need to be negative. You take the term over here, the 1, and divide by the coefficient of x, 2. So this is negative 1/2. X minus 5 also has to equal 0. X minus 5 equals 0. So we can move the 5 over and we can write x equals positive 5. And those are our answers. Technically, we should go back and plug them in to make sure that they work, but we're kind of running low on space. I guess we'll do the on your owns together. So this is one with a leading coefficient of 1. So we don't have to do the extra steps from last time. We've got to look for two numbers that multiply to negative 21 and add to plus 4. One of those numbers will have to be a 7. The other one's going to be a 3. So I know that this has to equal x plus 7 and x minus 3. I know that because 7 minus 3 is plus 4. That's important that it's positive. And I know 7 times minus 3 is negative 21. So it only works if the 7 is the positive and the 3 is the negative. This has to equal 0. So now at this point, we just take our brackets, set them equal to 0, and solve for x. X plus 7 has to equal 0. X plus 7 equals 0. So x must be negative 7. And x minus 3 also has to equal 0. So that means x has to be positive 3. We can then take this and plug it back into our original equation, and we can test to see whether these both work. If we want to test the 3, we would go 3 squared plus 4 times 3 minus 21 equals 0. I've just gone and taken x in my original equation, substituted a 3. So this will become 9 plus 12 minus 21 equals 0. 21 minus 21 equals 0, or 0 equals 0. So I know 3 is a solution. I can also test my other one. I can test out x equals -7. That one will be a little bit uglier. It'll be -7 squared plus 4 times -7 minus 21. And that's supposed to equal 0. So -7 squared is 49. Let's try that again. -7 squared is 49. 4 times 7 is 28, but this will be minus 28. Minus 21 equals 0. 49 minus 49 equals 0. 0 equals 0, and it works. Like I said, I'd like to see you testing these out for now, but it's not a step you have to do absolutely every time. All right, so this brings us to some trickier problems, the word problems, because we have to make sense of what the question's asking, and we have to figure out what math to do to solve it. So let's read through the question first. The path of a Jack Russell Terrier on a particular jump can be approximated by the quadratic function h of d equals -3/10 d squared plus 11/10 d plus 2, where h is the height above the surface of the water, and d is the horizontal distance the dog travels, and probably should be measured in meters since we use the metric system, but this question's in feet. We need to figure out the horizontal distance of the jump. So going back to what actually is in our equation, we've got this equation. This equation models the height above the surface of water, and d is the horizontal distance of the jump. So we need to start with our equation, and we need to figure out what distance d matches a height of 0. h of d, I'm just going to call it h. h equals -3/10 d squared plus 11/10 d plus 2. And now if we go back and we think about what's actually happening with the Jack Russell Terrier jumping, we can draw a little graph, and that might make a little more sense of what's going on here. We've got height in the y direction and distance, I guess it's in feet, in the x direction. And so the dog's going to jump up. It's going to reach some height. It's going to start at 0. It's going to reach some height. It's going to come back down, and then it's going to hit the ground again. The question is not asking what is the maximum height. It just wants the horizontal distance, and we need to keep this idea that the height goes from 0 up to some max, back down to 0. So if we set the height equal to 0 and we solve for distance d, that'll tell us how far the dog jumps. And that's what we're going to do. So let's zoom in a little bit here. We can rewrite this as 0 equals -3/10 d squared plus 11/10 d plus 2. And now we have to factor this, and it's going to be a little bit ugly. We've got fractions. If you remember before the break, when we had fractions like this, they needed to be eliminated to solve this. So what I'm going to do is I'm going to multiply everything by 10, and I'm going to eliminate my 10. So I can write the -3/10 d squared plus 11/10 d, and I need 2 to have a denominator of 10, so I can just multiply it by 10. I can write plus 20 over 10. And this all equals 0. Now that everything's divided by 10, I can just factor that out. So I can write it as 0 equals 1 over 10 times 3d squared plus 11d plus 20. And now I have to factor 3d squared plus 11d plus 20. So just as we've done before, you start by taking your 3 and your 20 and multiplying them together. So take 3 and 20, 3 times 20 equals 60. We have to then figure out the factors of 60. There's 1 and 60. There's 2 and 30. There's 3 and 20. There's 4 and 15. There's 5 and 12. And I think we can stop here. We need a pair that multiplies to 60, and all of these pairs will, but we also need a pair that adds to 11 somehow. And actually, one thing that we missed along the way is this was minus 3 over 10, so this should be negative 3d, and this will be negative 60. That does change things. We need to multiply negative 60, and any of these will do that, but we need to pick the pair that is going to be different by 11. The only one that is 4 and 15. The 15 will be the positive, because it has to add to negative or positive 11. Negative 4 will get us there. So now we can go and take this, we can write it out. I suppose we can just, well, we'll do it over to the side here. We can rewrite this as, I'm going to scrap the 1 over 10 for now. Technically, it should be part of our answer, but we don't need it. It's going to clutter things up. I'm going to write 3 minus 3d squared plus 11d plus 20. And this does equal 0 still. I'm going to split the 11d into 15 minus 4. So minus 3d squared plus 15d minus 4d plus 20. So I'm going to draw in my brackets. And technically, there is a plus sign between them. I'm seeing a lot of students are putting a dot, like a multiplication, but these are being added. So now we need to factor things out to try to make the brackets equal the same thing. We can pull out a d for both terms of the first bracket. We can also pull out a 3. So let's write 3d, and the bracket will be negative d plus 5. And now we want to turn the other set of brackets into negative d plus 5. We can pull out a 4 from the other set of brackets. So we go plus 4, and this will become negative d plus 5. At this point, the brackets equal the same thing, so we can go ahead and we can just factor this into 3d plus 4 times negative d plus 5, and technically this all does have to equal 0. So we can go and we can write this whole equation, sort of starting over at this point over here, in factored form. We can say 1 over 10, because it is still part of our answer, 1 over 10 times 3d plus 4 times negative d plus 5 equals 0. And now I know these brackets have to equal 0. So start with the first set of brackets. Let's start with 3d plus 4. 3d plus 4 equals 0. that means that 3d equals -4. That means d equals -4 over 3. Now, because we're doing a word problem, and because not all answers are going to work, we have to think about the context. We're asking about a distance the dog jumped. Dog isn't jumping backwards. We can throw this answer out. There's no negatives. So that's off the table. So our other one's probably going to be what gives us the solution. We can go -d plus 5 equals 0. Move the 5 to the other side. -d equals -5. Divide by the -1, and d equals +5. That's our answer. So technically, this is a word problem. We should write the answer out. The dog jumped 5 meters. Or sorry, this is not in meters, this is feet, 5 feet. Okay, one more problem. The length of a rectangular lacrosse field is 10 meters less than twice the width. The area of the field is 6,600 meters squared. Determine the dimensions of the field. So we could start by drawing out the actual field itself, and that'll help us visualize what's going on here. Oh, pretend that's a nice straight line. It says the length is 10 meters less than the width. So I can take or it's twice the width. So I can take the length and I can write it as twice the width minus 10. I can also take the other dimension and I can give it a label. Right now, the only info I know about the width is that it's the width, so we're going to call it W. So we actually have to build our quadratic equation this time. Maybe we'll stick it black. I know that area equals length times width, so I'm going to start there. Area equals length times width. I know what the length is in terms of W, and I know what the width is in terms of W, so I'm going to substitute length with 2W minus 10. I can go area equals 2W minus 10 times W. I've got to expand the brackets. And I also have to use an area of 6,600 meters squared. So I'm just going to leave it as A for now. We'll expand the brackets first. We have to do 2W times W, so 2W squared minus 10 times W minus 10W. I'm going to replace area with 6,600. 6,600 equals 2W squared minus 10W. And I'm going to move the 6,600 over. If you ever see something on the other side of the equation, it's not a trick. You just have to move it so that it's on the same side as the quadratic. So I can write 0 equals 2W squared minus 10W minus 6,600. And now we've got the equation that looks like something we've seen before. We've got to go ahead and factor this now. Fortunately, 2, 10, and 6,600 can all be divided by 2. So we can just remove that, and it doesn't have to be a complicated quadratic. We can write this as 0 equals 2 times W squared minus 5W minus 3,300. Now it's a little simpler. We need to think of two numbers that are going to multiply to 3,300 and that are going to add to minus 5. And now this isn't going to be something you can do in your head. You're going to have to start writing some lists of factors, and you're going to have to test some numbers. The particular numbers that will multiply to 3,300 and add to minus 5 are going to be 60 and 55. But I didn't know that until I tested it out with my calculator. So I'm going to have to actually start trying to divide 3,300 by numbers. But I know it's 60 and 55, so I can write 0 equals 2 times W minus 60. And it's the negative is the 60 because they have to add to negative 5. And the other one is going to be W plus 55. So now both sets of brackets are going to have to equal 0 to get our answers. First set of brackets, W minus 60 equals 0. Move the 60 over and we get a width equal to 60. We can use the other set of brackets to find the other solution. W plus 55 equals 0. I can move the 55 over, W equals negative 55. And if you were paying attention before, you probably notice that this is giving me a negative width, and we don't have negative widths. So that option's off the table for now. So we know the width. Width is 60. So now we can find our dimensions. We're almost done. I know the width is 60, and I know that the length is 2 width minus 10. I can plug 60 back into this equation. The length is 2 times 60 minus 10, which is 120 minus 10, which is 110. And now I've got my length and I've got my width of the field. Technically, we should write our answer. So the length of the field is 110 meters, and the width is 60 meters. And there you go. So this is going to take a bit of practice, and I don't expect that everybody is practiced up in their factoring, so it's going to take a bit of time. I've got some problems for you to try. The first few questions are very quick questions, but 7, 8, and 14 are the ones that really have to do with factoring and using factoring to solve. That's going to be the homework for today. It's all on your workbook. I know some of you might not have your workbooks yet, but we'll have to try and get them and work through this. I will try and be available for questions during normal class time today. I'll give you a window and I'll send you an email. Anyways, that'll be the end of the notes for today. Take care, and I'll connect with you all tomorrow.